With our definitions of real power and definitions of complex power, let's come back and take a look at what our reactive power might be. So remember, our complex power is a combination of both the real power from our resistive elements and our reactive power from our inductors and capacitors. And so this is normally plotted in a 2D plane where your real power ends up at some point out here, and again the major components are the average power and the reactive power. So if we were to draw a line down right here, we would have some real power value, and if we were to draw a line here, we would have Q, which would be some sort of reactive power value. And the reactive power comes because there is a difference between the voltage and the current phases, and so that gets expressed in this chart here with the phi z. And phi z is the difference between the voltage phase and the current phase. So the more out of phase it is, the higher up this reactive power might be. So if you're really out of phase, like there are a lot of reactive elements, your complex power might be higher up and it might have a larger angle. Versus in the other way, if you don't have a lot of reactive elements, maybe your complex power is a little bit lower and the phase angle is not as much. But either way, we can use this, because this is a triangle here, to look at what actually might be our definition of reactive power. And so we can say that if I take the tangent of phi z, then my relationship is going to be Q over P average. And rearranging, we can then say that Q is P average times the tangent of that phi z. And we've seen that for one of our definitions of P average, that is VRMS times IRMS, and then cosine of phi z times tangent of phi z. So this is our previous definition of average power, copied down in, and then a cosine times a tangent ends up being a sine function. So in the end, our complex power is VRMS, IRMS, sine of phi z. So remember, we had real power was VRMS, IRMS, cosine of phi z. Reactive power is going to be very similar, but it's going to be VRMS, IRMS times the sine of phi z. And the units for our reactive power are volts, amps, reactive. So we have to distinguish this from volt amps and from watts. And these are going to be called VARs. So volt amps reactive for our complex power.